So what is traffic engineering? It's a set of techniques to steer traffic over a path different than the shortest path calculated by IGP. Usually this requires some form of source routing, such as MPLS labels or Service6 extension headers. Traffic engineering uses some constraints, such as admin groups or bandwidth requirements, and it needs some method to map data traffic to the traffic engineered path. Many use cases, some of them are send latency sensitive traffic via a low latency path, and the rest traffic via the cheapest path. Send two streams of data via different paths, avoiding shared risk links. Load balance traffic over a custom network topology, and ensure that traffic is routed without congestion if some links fail and network reconverges. In this demo, we are showing a simple network with 5 ISP routers and 4 customer routers. CE1 and CE3 are part of the VRF VPN 101. CE2 and CE4 are part of the VRF VPN 102. We will use segment routing traffic engineering to map traffic within the VRF VPN 101 to the blue colored links, and traffic within VPN 102 to the yellow colored links. To achieve this goal, we have marked blue and yellow paths with the respective admin groups in the VyOS configuration. That is advertised into ISIS, and we have P2, which is a Juniper router. It advertises ISIS topology into BGP link state, which advertises to traffic dictator. We also have configured 2 service loopbacks on each P routers, and when we advertise the VPN, the customer routes, we change the VPN next hop to the respective service loopback using a route map. And here we have the traffic flows over blue and yellow paths. Then on traffic dictator, we configure SRT policies, mapping the relevant constraint to the relevant service loopback. In this example, the blue path is mapped to the service loopback 1, and the yellow path is mapped to the service loopback 2. Traffic dictator calculates the traffic engineering policies and advertises them to VyOS routers using BGP labeled unicast. VyOS resolves VPN next hop over these BGP-LU routes received from the controller. We also have configured a BGP-LU session between the VyOS routers. This is required for redundancy in case the controller fails or SRT policies fail. The traffic will not be dropped, but it still will be forwarded over the IGP shortest path. In this particular example, we have used admin groups, but we can achieve exact same behavior using different constraints. For example, if we don't care which path which VRF takes, we don't need to use admin groups. We can just configure both policies with the same disjoin group, and the path calculation algorithm on traffic dictator will ensure that policies within the same disjoin group never use the same links. And there are other options for path constraints such as bandwidth, explicit paths, different metric types, etc. The advantage of this solution is that it's simple and based on open standards, that is BGP link state and BGP labeled unicast. Therefore, it can be deployed in a multi-vendor environment, and it's easy for any network engineer who is familiar with BGP to operate and troubleshoot it. There is no need to support for any vendor proprietary protocols or extensions. BGP also makes it easy to design redundancy. The operator can deploy multiple controller instances. You can even deploy traffic dictator in a Docker container on a VyOS router itself. Even if all controller instances fail, that will not result in a catastrophic failure because traffic will just follow the shortest path. For mission-critical design, there is a straightforward evaluation checklist. First, controller redundancy, policy scope, what services are mapped to traffic engineering policies, and failure behavior. What happens in case of link failure, node failure, or controller failure. On VyOS, a key safety property is graceful degradation. Controller loss results in shortest path forwarding rather than complete traffic loss. And this makes failure design more predictable. Traffic engineering helps network operators to use their network resources more efficiently. Segment routing provides a scalable, open standard-based network architecture. Segment routing traffic engineering with VyOS and Traffic Dictator shines in these scenarios due to its lightweight containerized deployment without heavy licensing cost, paving the way for next-generation architectures such as intent-based networking.